So in this unit, we're going to start looking at what are called systems. So a system is two or more equations. So instead of just one equation, you're going to have two or more, but we're going to just do two. Okay. Like in theory, you could have 17 of them, but we're going to just do two. Does this make sense? Okay. So instead of just one graph, you're now going to have two. The solution or the answer, which is what you're trying to find, is a point that satisfies both of them. And so that would be where the two graphs do what? If it's a point that's on both graphs, it would be where the lines, good, intersect or connect, but we're going to use like the appropriate vocabulary. So the point would be an intersection. So where they meet, where they connect, where they bump into each other, it's the intersection of the two lines is your answer. So there's three different possibilities. You can get one solution, which would be graphs like this, where they just intersect one time and boom, right there where they meet, that's your answer. And so your answer is an ordered pair, like 7, 2 or 3, -8. Do you get what I'm saying? Like your answer is something, something else. All right. You could get no solution. And what would that look like if the graphs don't meet? Parallel, good, like this. And then there's a third option, which is infinite solutions. And this is going to look funny when I draw it, but it's where the graphs intersect literally everywhere. So you have a line, and then the other line is right on top of it. Like they're the same line. Do you get what I'm saying? So they intersect literally everywhere. So when you draw it, it looks like you're only drawing one line, but it's technically two lines where one is right on top of each other. I don't know how to draw that and make it look like two, but you get what I'm saying? Like they are the same line. So they intersect everywhere. And so you get infinite solutions. Okay, so like every number in the world, like every point ever is an answer, right? So for 1 and 2, it's just determine whether the given point is a solution or not. In essence, it's a yes, no question. So we have the point 15, 20. We're going to plug in 15 for X and 20 for Y and just see if it works. It's like a true false question. Now, I like the computers put away while I'm teaching. You know, you could use a calculator when you're doing this on a test, but we'll just work through it together. So look at the first one. We're going to plug in 15 for X. So you'd have 3 times 15 minus, and then what would come next? Times 20, good. And we want to see if that equals 5. Now, again, you could pull up your calculator and type this in and just see if it comes out to be 5. But let's see. 3 times 15 would give you, good, 45 minus 40 equals 5. Is that true or false? True. Good. It worked. Does that mean it's an answer? Not necessarily. It worked for that one. We have to check it for the other one. It has to make them both true. Okay, so let's try this one. It would be 6 times 15 minus 5 times 20. And we have to see if that equals -10 or not. In essence, it's a true false thing. So that'd be 90. Yes, minus 100. Sorry, you did that really fast in your head. I was trying to like make sure that was right. So is 90 minus 100 equal -10? Yes. And so the answer to the question is yes, or true, or whatever. It is an answer. So let's try that for the next one. We're just going to try it again. It's just like, hey, we did one example. Let's try another example. We're going to plug in -8 for X, -2 for Y. So it would be 5 times -8. I'm going to speed this one up a little bit. Minus 2 times -2 equals -36. And again, on a test or quiz, you would type this in your calculator and just see if it equals -36. We're going to work it out by hand. This would be -40. Oh, why is it plus? Good. Yep, two negatives cancel. So it'll be plus 4 equals negative 36. So is that true? Yes. And then you have to do the other one. So it'll be 3 times negative 8 minus negative 2. Good. I'm glad you're saying it, but are you writing it too? Like on a test, you would have to. But you were very good with your multiplication tables. That's awesome. So negative 24, ooh, plus 2. Does that equal negative 26? No. Negative 24 plus 2 would be negative 22. Good. So the answer is no. So the takeaway there is you have to check them both. Okay. And again, I talked you through that. On a test, you would type it in the calculator. Okay. Now here's all your steps for solving doing substitution. That's our lesson for today. It says it up there. I can solve a system using substitution. Real quick though, mathematics aside, what does the word substitution mean? Because you knew what that meant before you watched it. In place of. You remove something, you replace it with something else. You're substitute. You get what I'm saying? Okay, I didn't teach you that. You walked in the door knowing that. We're just going to relate it to the math. All right. So you're going to solve an equation for one variable. Pick the one that's easiest. A lot of times one of them will already be alone, which is great. So you don't even have to do step one. Substitute into the second equation. And I'm going to add something to that. You want to use parentheses. Give it a hug. Use parentheses. Sometimes you don't need them, but when you do, like if you have to distribute something, they have to be there. So make sure you use parentheses. And then you're going to solve. You guys nailed that back in unit 2. You were all great at solving equations. Just do that again. Okay, you're just going to solve it. And so you would find like x equals 3 or whatever. And then you would take that answer, like x equals 3, plug it back in to find y. So you'd plug back in the 3 or 7 or 12 or whatever you got, find the other variable, and then just make sure you write it as an ordered pair, something, comma, something else. Okay. If you get something that makes no sense, it'll be no solution. For example, 7 equals 5. Do you get what I'm saying? If it's infinitely many, it'll just be something that's always true. What would be an example of that? 7. Like 7 equals 7. We've done this before. Do we remember this? Yeah. Okay, we're just going to practice a whole bunch of them. You know what? I'm going to grab a highlighter real quick. And so what you want to do is look through and see what you have. Do we have one of these equations that has x by itself or y by itself already? Yeah. Do you see the second one? How y equals 3 plus x? Okay, so I'm going to take that 3 plus x and substitute it in for y in the other equation. Do you see the parts I highlighted there? If you don't have a highlighter, you can just circle it. We're going to take this 3 plus x and substitute it in for y. We're going to remove y and replace it with the 3 plus x. So here's what that's going to give us. X plus, and in place of y, we're going to put 3 plus x. Use parentheses. Give it a hug. Whatever you're plugging in, give it a hug. And then that equals 5. Now, here's where you just solve the equation. Again, you guys nailed this back in unit 2, so just do it again. Okay, stay awake over there. We actually don't need to distribute anything here because there's no number out front. We can go ahead and put the like terms together. What do we get if we put the like terms together? 2x, x plus x would be 2x plus 3 equals 5. And then what? Subtract 3. Make sure you show all your steps. I can't grade what happened in your head. And then divide by 2. Okay, hold on. Write it down, guys. 2x will equal 2. Good. And then divide by 2, you get 1. The thing is, you're not done. We found x. What do we still have to find? Y. So you're going to take this 1. You can plug it back into either equation. Do you remember when we were writing equations last unit and I said pick the first one for no other reason than it's the first one? I'm going to say the same thing again because you have to pick one and it simply does not matter. So just use the first one. Does this make sense? Just use the first one. Then you won't have to worry about it. All right. So we're going to plug 1 back in for x. That'll give you 1 plus y equals 5. Subtract 1, and what do you get for y? Y equals 4. Question.
Go back to like the y equation.
It doesn't matter if you use the first or second one. I'm just always going to say use the first one for no other reason than it's the first one.
I feel like y is second.
And it doesn't matter. So if you want to use that one, that's fine. Now, final answer, you can't leave like that. It has to be something, comma, something else. And here's where people lose their minds and they'll write 4, comma 1. Why would that be wrong? It's x, comma, y. Good. So just make sure you write 1, comma 4 and understand that if you graphed this, they would intersect at that point. That's what we did. We'll try one more and then I'll give you a break, okay? Do you see one of these equations that has a variable by itself already? Do you see how this first one's y equals? Okay, so that 2x plus 1 is going to get plugged in for y in the other equation. And if you don't have a highlighter, that's fine. You can just circle it and draw an arrow. Like, hey, we're going to take this and plug it in there. And you're going to give it a hug. Use parentheses. So that's going to give us 2x minus what? Parentheses. This whole thing, it's a substitution. You're taking that and substituting it in, equals 3. And then you just work that out. Now, this is really a -1 out front here. What are you going to do with that -1? Good, distribute. And that's why you need to make sure you put parentheses. If you don't, you're going to forget to distribute. When you distribute a negative, it's just going to negate everything that's in there. It'll all flip-flop its sign. So this will be 2x and then what? Minus 2x minus 1, good, equals 3.
Wait, so why for this one is there a 1 in front of the first? But for the last one there wasn't.
This one simply did not have anything in front of the y. This one had a negative sign. You don't have to put a 1 there. I just did because sometimes that helps. If you want to just think about distributing a negative sign, that's fine too.
So basically you would distribute the like positive 1.
Correct. Like this has a 1 right here. But if you distribute a 1, it like nothing happens. So you're right. Yeah, you're right. Yeah, this one simply just didn't have anything there, or if it did, it was just a 1, so it didn't make a difference. That's a really good question, though, and I'm glad you asked that because it ended up on the recording, so whoever would be watching this is going to see that. All right, so then what's going to happen here? Yeah, 2x minus 2x. Yeah, that's going to go away, right? 2x minus 2x. Like if you have 2 apples and you take away 2 apples, you have 0 apple. So we get -1 equals 3. What do you think? And what that means is if you graphed these, they never touch. They would be parallel. Okay. We're just going to practice a whole bunch more of those, but go ahead and take a mind break. So, hey guys, looking at number 3, do you see a variable that's already by itself?
X.
Do you see how in this one, x is already alone?
Yes.
Okay, so we're going to take all of this and substitute it in for x in the other equation. It's nice if you have one that's already by itself. And if you don't have a highlighter, you can just draw an arrow. So we're going to remove x, replace it with all of that. So it's going to be 3 and then what?
Or y minus 7.
And what goes around it?
No parentheses.
Parentheses, good. 4y minus 17, give it a hug. So hold on, let me get everybody there. It was 3 times, we took out x, replaced it with all of this, and then what would come next? Minus y equals 4. Basically, you're just finishing writing the line. And then you just solve that. You guys did great with this back in Unit 2, just do it again. What would you do with this 3? Thank you. Yep. Distribute it. Good. It'll be 12y minus, what is that, 71? Oh, wait. 51. I'm sorry, 51. Got a little carried away. 51 minus y equals 4. So we distributed the 3.
So you have to combine the y
Combine like terms. It'll be 12y
minus y.
minus y. What would that give us?
11y.
11y minus 51 equals 4. I love that you're saying it. Also write it down. On a test, I can't grade it if you've just said it in your mind. You have to write it down. All right, and then what? Add 51, good. Hold on. 11y equals 55, and y is 5. Not done. We found y, we still need x. I would plug into the first equation for no other reason than it's the first one, and you have to pick one, just do the first one. So we're going to take y, plug it back in for y. So if you look at the first equation, that would be 3x minus 5. We're plugging the 5 back in, equals 4, and then just solve that for x. Basically, since a system is 2 equations, you're doing 2 problems. It's kind of just 2 problems. All right, add 5. What do you get? 9. Divide by 3, you get 3. And your answer has to be an ordered pair. 3, 5. It's x, y. And again, if you graphed them, that's where they would collide. I like that. Intersect, though, is the official word. Look at number 4. Do you see one variable that is already by itself? No. That means you have to get one of the variables by itself. This one's going to have an extra step. Now you have to look. Okay, I'm starting to lose these. Yes, you're there, but I need to get everybody there. You need to pick a variable that is already sort of by itself. Ladies, can you keep that shut? You need to pick a variable that's already sort of by itself. Like you want to do the easiest one. Do you see how this x is already kind of lonely?
Yeah.
How could you get that x completely by itself?
Just do it.
Oh, you gotta
Subtract
3y.
3y. Good. Subtract over the 3y. Okay, hold on, guys. Let me get everybody together. You would have x equals 7 minus 3y. Do you see how we had to figure that out on our own, though? Okay, now I can highlight. We're going to take this and substitute it in for x over here. And if you don't have a highlighter, you can just draw an arrow. We're going to take all this, substitute it in for x. It's called substitution. So if one of the variables isn't by itself, you have to get it by itself.
Okay.
So that'll be 4 times what?
7.
And what goes around it? Parentheses. 7 minus 3y in parentheses. And then basically just finish writing the rest of the line. It would be minus 2y equals 0. And then you just solve that. And you have to write it. I'm like literally begging at this point. I can't grade what you did in your head. Good. Distribute the 4. You'll get 28 minus 12y minus 2y equals 0.
You would have to add 2y.
We're going to combine like terms. Negative 12y and negative 2y would be negative 14y. Very good. We're going to subtract 28. Okay, hold on. Negative 14y equals 0 minus 28 is negative 28. And you're correct. Let me get everybody else there. Divide by negative 14. Oh, what happens to the negatives? They cancel. So y is 2. Now, unfortunately, you're not done. These are longer problems. You have to do 2 of them. We found y. What do we still need? X. I would plug back into the first equation for no other reason than it's the first one. Do you see what I'm pointing at right here? Okay. We're going to take 2, plug it back in for y. That's going to give us x equals, I kind of ran out of space. I'm going to have to come down here. X equals 7 minus 3 times, what do we get for y? 2. So good. 3 times 2 would be 6.
which is 1.
7 minus 6.
So
So x is 1. And yes, you have to write it as an ordered pair. So it'll be 1, 2. And again, if you graphed it, that's where they would intersect. We're very unfocused right now. I'm only going to have us do a couple more problems. Let's just stick together here, okay? Look at this one. Do you see one variable that's already alone?
why?
Yes. Do you see how y is already alone?
Yes. I know.
So you're going to take this and substitute it in for y. And if you don't have a highlighter, you can just draw an arrow. So that's going to give you 2x plus 2 times what?
Negative x.
Negative x plus 16. Put parentheses around it. So we took all that stuff, plugged it in, substituted it in for y, and then equals 2. And then you're just going to solve that. What would be your first step?
What you have to distribute it.
Distribute the 2. It'll be 2x minus 2x plus 32 equals 2. And then what happens?
32 does not. In fact,
You get 32. 32 does not in fact equal 2. So no solution. These ones are word problems. It works out the exact same way. You just have to write the system yourself, okay? You're going to have an X and you're going to have a Y. There's going to be 2 things. Let's read the first one. Chase got a 1340 on his SAT. You understand that's really good, right?
you need a 14.
Go Chase. All right. Do you know what the highest score is?
14.
1600. Because it's 800 and 800.
I could do that.
His math score was 400 points less than his verbal score. What were the math and verbal? X is going to be math.
Less than 400.
Y is going to be verbal. Those are the 2 things that are going on. That's always your first step, is to define those. What is X and what is Y? Do you have to write that down? Yes, or you're going to forget which one's which.
Why not this?
Okay, X is math, Y is verbal. Now you have to write the system yourself. If his total is 1340, his math plus his verbal, X plus Y, is going to be 1340. And then here's the other piece of information. Math is 400 less than twice his verbal. So X is math, X is, so X equals, how would you write 400 less than twice his verbal score? This is back from unit 1. This was like one of the first things we did, was like interpreting these. 400 less than twice his verbal.
So 400 minus.
Verbal is Y. How would you do twice his verbal?
So 8.
Twice his verbal would be 2. Good. 2 times Y. Perfect. And you want 400 less than that. So minus 400. Good. Got us there. Is one of the variables already alone? Which one? X. So you're going to take this, substitute it in for X. If you don't have a highlighter, just draw an arrow. Are you sure? Okay. So you're going to take that, plug it in for X. It'll be 2y minus 400 plus y equals 1340. Now there's nothing to distribute. Or like you were saying, there's technically a 1 here, but if you distribute a 1, it's just the same thing. Okay, so we can go ahead and combine like terms. What do our like terms give us? 3y minus 400 equals 1340. Stick with me, guys. We're almost done. And then you would add 400. Okay, can you hold on? So add the 400. It'll be 3y equals, what is that, 1740? And then last step is divide by 3. I don't actually know what that is off the top of my head, so hold on, let me type it in really quick. 1740 divided by 3. 580. So y is 580. What do we still need? X. You're going to take y, plug it back in. I always say use the first equation, no other reason than it's the first equation. It would be x plus 580 equals 1340. And so what would you do to get x by itself? Yep, subtract 580. And I'm just going to type that in as well to make sure that I don't mess it up in my head. 760. Now this one, if you don't write it as an ordered pair, that's fine because it's a word problem. But let's understand what it means. Which did he do better on, math or verbal? Yeah, this one's his math. This one's his verbal. But he still did really well. Better than a 1340? That's a really good score. Anything over 1,000 is pretty good.
I got perks on my-
Didn't you guys take the PSAT earlier this year? Didn't they make you do that? Did you get your scores back? They should have given them back to you. All right, let's try one more. Oh, this one's about football, guys. At the end of the football season, 31 games have been played with the leagues, AFC and NFC. So those are the two things that are going on. We're gonna let X equal AFC and Y equal NFC. So that's your first thing is what are the two items? Like what are the two things going on?
Conference.
All right, now if there's a total of 31 games, how can I write that equation? It's like what we did up here. His total was 1340. If there's a total of 31 games, what's the equation we would write? Good. X plus Y equals 31. Total is 31 games.
Can't you just subtract 5 from 31 and divide by 2 and add 5?
But I can't grade that because you did it in your head. So you have to write it down. I don't know how many times I have to say this. If you just write an answer, I can't give you credit. You have to show me what your thoughts are. You'd have to write a paragraph explaining what you just did. Easier to do this, trust me. NFC, which what was that, X or Y? Y. NFC won 5 more games than AFC. So Y equals what? They won 5 more. What plus 5? Well, Y equals X plus 5 because they got 5 more. Is one of the variables already alone? Yes. Which one's already alone? Y. So you're going to take this, substitute it in for Y. If you don't have a highlighter, just draw an arrow. What will that give us? X plus 5 equals 31. There's nothing to distribute. So you can just go ahead and do like terms. That would be what? 2x plus 5 equals 31. Subtract 5. Can I call this the easy part? Is that okay? Like we're okay here. 31 minus 5 be 26. So X is 13 games, I guess we'll put for like our units there. So AFC played 13 games. How do we get Y? Put 13 back in. It would be 13 plus Y equals 31. And you would subtract 13. Y would be, what is that, 18?
Yeah.
So who played more games, AFC or NFC? NFC played more.